In this video, we're going to be talking about sections 11.5 and 11.6, which are about circle circumference and circle area. Circumference is a word that stands for perimeter for a circle, so it's the perimeter of a circle. The circumference is equal to pi times the diameter. Diameter, of course, is 2 times the radius. So pi times 2 times radius. Or we could rewrite it this way without parentheses. Circumference is 2 times pi times radius. The area of a circle is pi times the radius squared. I like to use this version of circumference because it compares well to area. They both have a pi, they both have an r, and they both have a 2. The only thing to remember is that the 2 is the squared part for area. And one way to remember that is anything that is area has a square in it. And I sometimes use the word squarea to remind me that area is the one with the square, not circumference. So basically it's algebra time because we have these two algebra formulas. If you tell me R, I can tell you A. If you tell me C, I can tell you R. All right, so here are 3 examples. In the first, given the radius, r, what is the circumference in the area? Given the circumference, what is the radius in the area? And given the area, what is the radius in the circumference? And we're just going to use algebra and the previous 2 equations. In the first problem, I just write my circumference formula, 2 times pi times the radius. I plug in my radius, 2 times 5, 10 pi. And just leave the pi in the problem. We don't need to go to the calculator and multiply 10 times 3.14. We can just leave it just like that, 10 pi centimeters. Again, for area, I write the formula, I plug in the 5, but this time I have to square it, 5 times 5. So that's 25 times pi. That's an exact answer. Again, I don't need to plug in 3.14. It's not wrong, but I don't have to do that. But my area has the units of centimeters squared. In my second problem, I write the formula for circumference, but this time I plug in the 36 pi into the other side for C, and then I'll divide both sides by 2 pi, 2 and pi, in order to solve for R. Once I have my answer for R, I can then plug the R in to find my area. My area is in feet squared, but I probably should have some units on my radius as well. Radius is a length, so that would just be 18 feet. The only thing that's going to have squared units is the area. In the last problem, I start out the same way. I see that I've been given area, so I'll write my area formula. Start with what I'm given. I plug in my area. I divide both sides by pi, and something squared equals 81. So R must be 9. 9 squared is 81. So I'm going to write that with units. R equals 9 millimeters. And as well, I'll plug that in to my circumference formula to get 2 times 9, 18 pi millimeters for my circumference. In this next picture, we have a circle, which is centered at point O. And we have a minor arc from A to B. And we're looking for, and the central angle is 80 degrees, AOB. We're looking for the measure of the arc. And when you see the measure of the arc, that means we want a degree answer. And we're looking for the length of the arc. I see here that the radius is 4. There's no units on that, so it's just the number 4. And I'm also looking for the shaded area. The length is a fraction or portion of the entire circumference. The shaded area is a fraction or portion of the entire area. So we previously learned that when the central angle is 80 degrees, that the measure of the arc is the same amount of degrees, 80 degrees. But now we're talking about the arc not just as degrees, but the length of the arc. And so we're going to say that it's like the circumference, 2 pi r. However, it's only a fraction of the circumference. What fraction is it? Well, when the central angle is 80 degrees, it'll be 80 out of 360 times the circumference. Same for the shaded area. It's not the whole area. It's a fraction of the whole area. And the fraction is 80 degrees out of 360 degrees. 80 out of 360. Use the central angle for your numerator of the fraction and use the regular formula for circumference and area. Now I could do this as before, where I do 80 divided by 360 times 2 times 4 and just slap my pi on the end. Same here, 80 divided by 360 times 4 squared, and slap the pi on the end. But this time, because my number in the front is already a decimal number, I think I'm actually going to multiply 1.77 times 3.14 and make one decimal number. So if it's a whole number, like 16 pi, I'll leave it. But if it's 1.77 pi, I'm going to multiply those together. Remember that in this problem we did not have any units to start with, so we will not have any units to end with. Again, if there's a decimal before the pi, let's multiply it out. Here are a couple examples. In the first case, we're given the central angle AOB, and we're given the radius with units. We're trying to find the arc length, so not an angle, not 80 degrees of measure, but the actual length in feet, and the sector area. Now the sector is the word that's used for this portion of the area of the circle, sector area. In the second case, we're given a diameter, and we're given at AB is 10 millimeters. Now it didn't say length, but I know it means length because they gave me a millimeter, not a degree. So that's the arc length from A to B. And we want the central angle, and we want, in this case, the unshaded area over here. And solving the first problem, we remember that an arc length is equal to a fraction of the circumference. The fraction being the central angle over 360 times the circumference formula, 2 times pi times the radius. I type that on the calculator, and I rounded off 4.19 feet. Sector area is 80 divided by 360 and times pi r squared being the entire area. I typed that all in the calculator. First I typed it all in without the pi, and I saw that it came out to a nice even 2. So you could write 2 pi, but if you type the entire thing in the calculator and get 6.28, either way it's feet squared. Either of those answers is fine. In the second problem, we are given the diameter, so we know what the radius is. It's half of that. We are given the arc length, and arc length is a fraction of the entire circumference. I don't know what the fraction is, the angle, the central angle, so I just call it x. And I can do 2 times pi times 4 divided by 360. I can put all those numbers together to make one number, and so I have that one number times x equals 10, and I can take 10 and divide it by 0.7 to solve for x in degrees. Now, I want the unshaded areas over here. Now, I know that this central angle is 142.86. I know that the entire thing is 360. So this big giant angle over here is what adds to this to make 360. So I figure out what this very large angle is over here, 360 minus my central angle. And then that is the fraction over 360 that I multiply times the area formula, pi r squared, to get my area of the unshaded part of this circle. All right, here's a little review of what we have done in this video. We've talked about circumference and the formula for that. Circumference is like the perimeter all the way around a circle. We've talked about the area of a circle and the formula for that. And each formula has a 2, a pi, and an r in it. But for area, it's squared. The arc length is a part or a portion of the circumference, or fraction of the circumference, and the fraction will be based off of the central angle times the circumference, where the sector area is a portion or fraction of the entire area based off of the central angle over 360 times the full area. Now, in many math courses, we don't like to use words in our formulas. We like to use a letter for it. So arc length is often replaced with a small s, and sector area in math textbooks often replaced by a small k. Won't get into the history of why that is the case, why they chose those letters, but you can sometimes see that. And also for angles, I know we used the x in our last problem, and x is a good variable to use, but many times in math courses when the variable is for an angle, they'll use a Greek letter, which is the letter theta, and use that over instead of x. So with these formulas here, these four formulas, you should be able to do many of the problems in section 11.5 and 11.6, but not all of them, and many of the problems that will be on our worksheet and our review, but not quite all of them.